Today we're going to be going over the answers to the Unit 11 review. So I'm going to start off really quick, and it looks like we have class M equals class A. So the storage type is class A, the variable is called M. It equals a new class A5. So our M object has an A value, we send 5, and it says this A equals 5. So M's A is equal to 5. Then we say class B equals a new class B. That calls the default constructor here, which says super1. Super1 sends up a 1 to class A, and it sets its A value to 1. Then we set our B value to 9. This is all the data for the N class. N object. So MA would be 5 plus NA, which is 1, plus NB, which is 9, giving us a total of 15. So we add all those together. They're all numbers, so there is no concatenation. So 15 is our final answer. All right, let's go ahead and move on to the next problem. Wow. This one is a very long problem. Oh, never mind, it's 2 problems. So I forgot to write the number 3 right there. So we'll call this problem 2.5. This here is problem 2. So there are 2 problems on this page. Public static void main string bracket bracket args. Test 1 equals a new test 1. So we have a test 1 object, and it has a method called text. If you say a.text, it will system.out.print its text, which is Bob. And this problem is done. Now let's scroll down to problem 2.2. All right, for problem 2.2, we are working right here, and we do test2 equals a new test2. So we're creating a test2 object using the default constructor, which is hidden because we wrote 0 constructors. Then we call the double text method. First, we say text. That will do whatever's in this file. Whatever's in its class, because this guy has B has a text method, and that text method would be Joe, because B is a test2 object. So it would be Joe. Then we do super.text. That would do your parent class's text method, which would be Bob. Then we do this.text, meaning myself.text. If I'm talking about myself, my text method is Joe. Joe, Bob, Joe. All right. Let's move on to the next question. It's another similar question. Clear. Here I say I have a test2 object, and it stores a test2. A test2 container, it stores a test2 object. If I say b.text, that will call the text method that B owns. And since B is truly a test2 object, it'll be a test2 text method, which will be right here, and it would print Joe. Clear. Now we're going to move on to this next problem, which isn't too bad. We're creating a new M object, and because I'm going to have to scroll back and forth, I'm going to go ahead and write what's happening. And that's going to be MA equals a new M. So we're going to find out what happens when you create an M. So we don't need the N class at all for this question. So we call the L method. The L method prints L. Then we call the Q method. The Q method goes here. It prints Q. Then it calls the L method, which will print L. And our answer is LQL. This next one is crazy. So it's extremely long, but we're going to work through it. So we say M, A, it's a container type is M, and it can store a new N. So creating an N object. And now we're going to have to walk through what's going on with this one. Bear with me, this problem is really long. So, right here, when we call our N constructor, there's a hidden line of code. Remember, if you do not call your parent constructor, it calls your parent's default constructor. So the first thing we have to deal with is calling super parenthesis parenthesis. And when we call super parenthesis, it'll run the L method. And this is complicated. It doesn't actually run the L method in the M class. What we created was an N class. So anytime you see L, it means it's referring to the one that N owns, even though we're up here. Because what the object we're talking about is really an N. So anywhere you see L, it's going to run N's L. So we go down here. The first thing, I'm just circling that line that's being processed, is going to be L. Then we run the Q method. When we run the Q method, it's this guy's Q, which is super Q. Super Q is going to print a Q. Then it's going to print L, which is this L method, which is L. That will finish off the super Q. Now it'll do QQ. Then it will run the L method, which is LL. And that will finish that invocation of Q. So now all we finished is the super line of code. Then we call L, which will print LL. Then we call the Q method, which does super Q, which is Q, and then an L method, which is LL. Then we print Q. Then we call the L method, which is the local L, and it prints LL. I did not intend for this to be this long, but it is. And the main part is remembering to do this super parenthesis at the beginning. Because if you do not list a call to your parent class constructor, it will do a call to your parent class constructor. It'll call your parent's default constructor. All right, let's move on to the next problem. Don't worry, it's not this long. Or is it? Seems pretty long. Here, what is wrong with the below code and what kind of error does it produce? So let's just scroll through and see what's wrong with it. We're going to go line by line. Class B, G, equals a new class A. Class A, class B extends A, so a B can hold a class A. Let's look if class... Oh, hold on. I misspoke there. Can a class B store any class A? No, because class A is a parent. All class Bs fit the category of class A. But all class A's do not fit the category class B. So what we'd write down is class B variable. It's taking forever to write it this way. Cannot store a class A object, and this is going to be a syntax error. So a child class cannot store its parent class. All right, another one. What is wrong with the below code? Let's start down here and see what it does. Class A. Can a class A hold a class A? Yes. Is there a constructor for class A that receives two numbers? Yes. So that's perfectly fine. Now let's go see what they did. B.getB, is that a method in class A? Yes. B.getC, is that a method in class A? No, there is no getC method. Class B has a getC method, but we didn't create a class B. We created a class A. Clear? Class A has no getC method. And this is a syntax error. All right, we can move on to the next one. Got to figure out why the next one has an error. All right, class A equals a new class B. Can you do that? Yes, because all class Bs fit the category of class A, because class B extends class A. So all class Bs are class A. And then we do the getC method. Does the class B have a getC method? Yes. All this code looks fine, but it actually doesn't work. The reason this doesn't work is the computer believes what we are storing is of type class A. So because of that belief, the computer sees K as type class A. So cannot find method, or cannot find symbol. And this is a syntax error. If you wanted to fix it, how you would have fixed it is you would have said, computer, believe me, this thing is a class B. What's a class B? K. Then you would do getC. You would override what the computer thinks, and this code would work. All right, let's move on to another problem. I can tell this review is going to be a while, so I'm sorry about that. It is the way it is. All right, here's another one where I'm asking you, why does it have an error? I want you to identify why things don't work and why they don't work. Class A equals new class A. All right. Oh, there's no default constructor for class A. You might be, well, it has the hidden default constructor. No, it only has the hidden default constructor if you write 0 constructors. So, no class A default constructor. And this is syntax. I don't know why I asked what type of error it was. It seems like all my choices were syntax. But that's fine. All right. Now let's move on to the next one. Why does the next one have an error? All right. I create a new class B. This class B calls super, just like you're supposed to. But again, no default constructor. I put this one in here twice on the review. I have no idea if it's on the test or where it's on the test because I wrote the test a while back ago. But again, this one's going to be missing default constructor because class B tries to use super parenthesis. So super parenthesis would be the class A constructor. No class A, and that would be the default constructor. So I should have left what I had written already on here. Default constructor. And this is again a syntax error. So that one's out the way. Let's go see what our next problem is. What is the output of the following code? Yay, we're doing something that actually does something now. So there's not any problems with the classes anymore. So I fixed any issues that there were. So class A equals a new class A. So if you go to class A, it receives 8, then 7. So it receives 8, then 7. This dot A equals 8. This dot B equals 7, the thing that was received. So then we print A, and then we print B. So this one's pretty easy. When you access A, it's 8, and the other guy's 7. All right, let me play catch up on my key just so I'm on the right page. No constructor, no constructor, 8 and 7. Cool. Here's another one. We create a class A, it stores a class A, so it's an 8 and a 7, A is 8, B is 7. Then we call test. What does test do? It returns A plus B. Well, we know that A is going to be 8 and B is going to be 7 because this one's the same code. I won't make y'all watch the entire review of me going through that and figuring it out again. This one was the same code. I had copied and pasted. So this was an 8, this was a 7, 8 plus 7, 15. All right, here's another one. Here's class A. So the computer believes we have a class A, but we're really creating a class B. So this is where it gets a little more interesting. I receive nothing. I say super 8, 7. So that means my A is going to be 8 because I receive A first. My B is going to be 7, and my C is 55. When I go to run test, how it decides if I can run test, it says, does class A have a test method? Yes. So we're allowed to run it because the computer believes it's a class A. But when it actually goes to run it, it runs the method based on what it is. It is of type class B. So it runs the B method. This is 8 plus 5 minus 55. So that's 8, 15, minus 55, negative 40. So let's clean that up a little bit so I can tell. All right, let's clear that and keep moving. What is the output of the following code? We're doing the same thing again. Class A equals a new class B. Now we're going to say cast R as a class B, which it is. And then do get C. It will like this. Without this cast, it would have an error because the computer believes I think it's a class A, so it does not let you run the get C method. But if you tell the computer, hey, it's class B because I'm telling you so, the computer will believe you. And then when you do get C, it'll try to do it. Now, if it really wasn't a class B, it would crash your program. But it is a class B because that's what we created. So when we do get C, that would be 55 because we use the default constructor, and that sets C to 55. All right, now we're going over writing code. And I'm going to pull up Notepad for this because I'm writing a lot of code, and I'm not going to write a whole lot of code with that little pen that doesn't work well. Write, that says and, write an interface named measurable. So public interface measurable. It will have two public double methods that are abstract, one named area and one named perimeter. Public abstract double. Why did it say capital area? I shouldn't have said capital area because it's a first name, first word in a method. So that shouldn't be capital. Public abstract double perimeter. And there's the interface. Interfaces can have public static final attributes, and they can have abstract methods. They don't have constructors. They don't have normal attributes. They're pretty easy. If I ask you to write an interface, it's pretty easy. So make sure you make note of this example. I might make you write an interface on the test. All right, let's move down to the next question. Write an abstract class named student. It will have the following stuff. So public abstract class student. It will have private string first name comma last name, and this is perfectly fine. You don't have to do it on separate lines. Private int classification. Now it's going to have some public static final variables. Public static final int freshman equals 9. Public static final int sophomore equals 10. Public static final int junior equals 11. Public static final int senior equals 12. That's all that stuff I ask you to do right there. Write a constructor that receives and sets first name, last name, and classification. Abstract classes can have constructors. Public student string first name comma string last name comma, we'll finish out on the next line, int classification curly brace. There's a lot of typing on this test, so just be ready for that. This dot first name equals first name. This dot last name equals last name. This dot classification equals classification. Okay, all that's done. Now I need to write accessors for all three of those things and mutators. This is a pain, but I'm going to copy and paste. Public string get first name, return first name. And now I'm lazy, so I'm going to copy and paste that. Control C. Get last name, int get classification, get classification. Now we have to write mutators for all these. And again, I'm going to be lazy after I write my first one. Public void set first name. It receives string first name. Then we do this dot first name equals first name. And then that should be set last name, set last name, set last name, set last name, set classification. It receives int classification. Control C, Control V, Control V, and we're done there. Now it says abstract method GPA, and it should say double. So that's going to be public double GPA, and it's supposed to be abstract, so we'll put in a semicolon at the end, and we'll put the word abstract. All right, that finishes out everything for this class. I know it's a lot of typing. I'm sorry. On the AP test, you're going to have a lot of writing. I'm sorry. All right, let's move on to the last question in the review. Given a class called person that has a first name, last name, and has a toString that does last name, first name, we're going to have directions. We're going to build a class that extends person. It's called teacher. We're going to use the following rules. So let's go back to my notepad and get started. Control A, delete. Public class teacher extends person, because a teacher is a person. They have feelings. Okay, private string teacher ID, private array list, angle bracket, person, students. They have an array list of students, which are people. Private int teaching experience. Then we have to have a constructor. Public teacher, and it receives a lot of stuff. It receives string first name, comma, string last name, comma, string teacher ID, comma, int teaching experience. Receives all those things. The first thing it has to do is set the first name and last name of this person. You do that by saying super first name, comma, last name, semicolon. Then you would say this dot teacher ID equals teacher ID. This dot teaching experience equals teaching experience. And I'm not enjoying doing this, and I know you're not going to enjoy it on the test, but we need the practice. That's your constructor. Write accessors for students and teaching experience. So I'm going to go ahead and take care of those. Public array list person get students, curly brace, return students. Public, what is it, teaching experience? Int get teaching. Did I not have a right one for teacher ID? No. Get teaching experience. This one's pretty easy. Return teaching experience. Now we're going to write a mutator for teacher ID. Although we don't have an accessor for it, we're going to have a mutator. Public void set teacher ID, and it receives string teacher ID. Then what do we do? This dot teacher ID equals teacher ID, semicolon, and other methods. Write a method named increase teaching experience that adds 1 to the teaching experience. Public void set teaching experience. It doesn't say it returns anything, so that's why it's void. Not set. It's called increase teaching experience. So after somebody's taught for a year, we would call this method. And it's going to be teaching experience plus plus. Finally, write a method named, oh, not finally, we still have some other stuff to do. Public void add student. So if you need to add a student to your class, they would be a person S for student. And then you would just say students.add S. All right, and I believe the final thing we have to do is write a toString that prints the teacher name, the teacher ID, should show the teacher ID, then students and every student in the class. So it's not actually so bad. Public string toString. String S equals quote quote, and it's going to say teacher plus super.toString plus \n. What this does, it goes to the parent class, which is person, and calls its toString, which already sends your name in the format of last name comma first name. Then we'd say S plus equals, let's see, ID colon plus, oh, I was supposed to have a colon space here, colon space, plus teacher ID, and now we have to do all the students. S plus, oh, we got the \n. S plus equals students. I want to list off all the students that are going to be in the class. This part's easier than you would think. All it is a for each loop. It goes person P colon students for every student in the list, column person P. And then what we do is we say S plus equals S dot toString plus \n. And you don't actually have to call the toString method because you would be joining it to a string. It would automatically invoke the toString method for you, which is awesome. And then once we're done with that, all we do is return S and bam, the class is done. And so is the solutions review video.